Okay, so moving on to part B, Sally takes part in a number of different races in the competition. The probability that she makes a false start in any given race is 5%. Find the probability that she makes her first false start in her fourth race. Give your answer correct to 4 decimal places. Okay. So I suppose there's 2 ways we could really do this. So first of all, I'll write as a decimal, I think 0.5. Now that's for a false start. That's S there, sorry. And then 0.95 would be, I suppose we'll call it a normal start. So a proper start. Now, find the probability she makes her first false start in her fourth race. So what that would mean is, in the first 3, she'd have a normal start, normal start, normal start, and then she'd only have a false start in the fourth one. So that's one way of doing it, I guess. So we could do 0.95 by 0.95 by 0.95 by 0.05. Now, that's coming out to be 0.04286. Now it says correct to 4 decimal places, so 0.0429. Okay. Now, so it's only about a 4% that will actually happen. Now, what's another way of doing it? I suppose you could do the one that we did with you know, the Bernoulli stuff. I'll just find that in your tables. Where is it again now? Yeah, so page 33 of the tables. So you know the, sorry, did I say Bernoulli there? Binomial, I should have said. So you know the way you might have out of the first 3, in all 3, so 3, choose 3 basically. So out of the 3, all 3, so choosing all 3 of them, she would have had a normal start. So 0.95 would be, I suppose, what you'd call the success. So it is a Bernoulli question, but I'm using the binomial distribution on page 33 to answer this Bernoulli. Bernoulli is anything that is, you know, success and failure. So in this case, I suppose success would be starting properly. And then not starting properly would be the failure. Now, what we do then is if you follow the formula on page 33, you can see the bottom number goes there, and then 3 take 3 is 0. So in your formula, you'll notice that on page 33, and you're looking for binomial distribution formula. And then and, now because it's and, it's multiply. So then it says and in the fourth race, so from that last one, choosing 1, in other words, from that one of those. Now this time we want her to have a false start because that's what we're looking for in the fourth race. And then the opposite of that would not be having a false start. So we do the same thing then again, the 1 goes there, 0, 1 take 1 is 0. Okay, so we end up getting 3 choose 3 is 1, 0.5 cubed, and anything to the power of 0 is 1, multiplied by 1 choose 1 is 1, 0.05, and then anything to the power of 0 is 1. So you can see there, you actually end up getting exactly the same answer if you were to do it that way. So it's kind of up to yourself. The first way does look easier, but in some of the questions, the Bernoulli method, Bernoulli trial, is less complicated. So it kind of depends on the question. So anyway, either way, you can choose. Okay, 20 relay teams took part in the competition. For any particular team, the probability that they drop the baton at some point during the competition is 0.1. Okay, so 0.1 is dropping it. So that means 0.9 is not dropping it. Find the probability that at most 2 teams drop the baton during the competition. Give your answer at 4 decimal places. Now, it's saying at most 2. So what you're really saying is you could have the probability that no one drops it. You have the probability that one team drops it, or you have the probability that 2 teams drop the baton, but no more than that. It says at most 2. So there are your 3 scenarios. And these are or. So it could be that no one drops it, or one team drops it, or 2 teams drop it. So when I go to do my answers in a moment, remember or is plus. So I do not multiply my answers. Like in the last question here, these are and. So it says, you know, didn't have a false start, and didn't have a false start, and didn't have a false start, and did have a false start. So these are and. Anything to do with and is multiply. Anything to do with or, one or the other, is addition. So just be careful with that one. Now, the probability that nobody drops it. So out of 20 teams, nobody drops it. So now I know this looks a bit strange now because we're about to say now 0.1. So somebody dropping it, that doesn't sound like that's your success, because remember, this is Bernoulli again, success, failure. So I know success in actuality is not dropping the baton, because you don't want to do that. But in the context of the question, dropping it is the thing we're looking for. So when we say success, it's the thing we're looking for. Whether that's good or bad in theory is besides the point. So that's why I've put the 0.1 there, 0.9. So what ends up happening, of course, again, is the bottom number goes here. So this is, again, your binomial distribution formula, page 33 of the log tables. And then you've 20 take 0 is 20. And it makes sense anyway, because you're basically saying that nobody's dropped it, and 20 of the teams, you know, have kept it in their hand. And then we do the same thing here, only it's 20 choose 1. So one team has dropped it basically, and the other 19 teams have not. And then out of the 22 teams, out of the 20 teams, 2 teams have dropped it, whereas the rest of them have not. So I'm going to work out my answers, but remember, we're adding the answers. So just be careful with that. We are adding the answers. So 20 choose 0 is 1. Anything to the power of 0 is 1. So we end up with 0.9 to the power of 20. Now that's coming out as 0.121576. I'm just keeping in a few decimal places there. Now 20 choose 1 is 20. And that's 0.1. And then we have 0.9 to the power of 19. So 0.9 to the power of 19. So that's giving me 0.135085. Again, I'm leaving in a good few decimal places until the end. 20 choose 2 is 190. 0.1 to the power of 2 is 0.01. And then 0.9 to the power of 18 is 0.150094. And again, leaving in a lot of decimal places there. So my top number, well, that's just 0.121576. The next one is 20 times 0.1 times 0.135085. So that's coming out to be 0.27017. And here I have 190 times 0.01 times 0.150094. Okay, so these are my numbers. Now remember, I am adding them. So I'm going to add those together. 0.121576. So when I add all these together, I get 0.676924. Now 4 decimal places, 0.6967, sorry, 69. So the probability, is around 67.69%.